All right, so picking up from our last lesson, yes, we do need to use logarithmic differentiation here because it does involve the x in both the base and in the exponent up there. So first step in using logarithmic differentiation, go ahead and take the log of both sides, and of course I do like to use the natural log of both sides because it's going to make the derivative part easier. So natural log of whatever that was. And remember, the point of doing the natural log of both sides is that it allows us to get that x out of the exponent here. Because according to our exponent rules, that becomes multiplication out front of our logarithm. So the natural log of y is going to equal ln x, so that's the exponent, times the natural log of the sine of x. So all I did was pull that exponent out front. In this case, it just happens that the exponent is a natural log. All right. So from here, I think we can go ahead and, now that we got the x out of the exponent, just take the derivative. And so we take the derivative implicitly, both sides here. So on the left side, that gives me 1 over y times y prime, or y prime over y, if you prefer to go straight there. And then on the right side, notice it's the natural log of x times the natural log of sine x. You're going to find whenever we do these, you're going to end up with some product rule to use on the right side, and we do here. So product rule, first derivative of natural log of x is 1 over x, and that is times the original other part, so ln sine x, plus, now in this case, the natural log of x stays the same, and I do the derivative of the natural log of sine x, and so that's going to be 1 over sine x. That takes care of the derivative of the natural log. But because it's the natural log of a function, I now need to use chain rule, multiply it by the derivative of that function, which is cosine of x. From here, it's really a matter of cleanup. Get y prime by itself. So y prime equals y times the natural log of sine x over x, plus, now I have natural log of x times cosine of x over sine x. The cosine over sine, I can simplify that a bit, right? Cosine over sine equals cotangent. So I'm going to go ahead and go there because that seems a bit simpler to look at here. So sine of x times cotangent x. If you chose to leave it as natural log of x times cosine of x all over sine of x, that would be okay, that would still work out. Now, I'm going to go one more step here, one last step, and that is I'm actually going to substitute in for y what y equals, which of course is our original equation that we are given. And that's what we'd then be looking at for our final answer here, where we've now written the derivative, y prime, solely in terms of x. So now we don't even need to know what the y value was. All we need was the original x, and we can plug in and find out what we're looking for. All right, so you're now finding this derivative. When doing this derivative, do you need to use logarithmic differentiation? Nope. Because we have the x in the exponent up here, but it's not in the base. The base here is just 7. So we do not need logarithmic differentiation here. Now as you're looking at this one, if it's giving you a little bit of trouble thinking about how am I going to now find this derivative, you can always make it a little bit easier to kind of process through what you're looking at with a set of parentheses. Because if I were going to put in parentheses, that's really where they would be. This is saying it's 7 to the power of a function. That function is x squared. And so I'm going to end up finding the derivative, y prime equals, by first finding the derivative of 7 to the power of something. That ends up giving us 7 to the same thing, the x squared, times the natural log of 7. So that's the derivative of 7 to the power of whatever it is. But because it wasn't 7 to the x, it was 7 to a function, I'm now using chain rule. I have to multiply that by the derivative of that exponent. So the derivative of x squared, which is 2x. And from here you can simplify anything you can, but there's not really a whole lot to simplify. If you went ahead and ended it right there, I'd be okay with that. All right, now with this problem, again, we always start by asking ourselves, am I going to need logarithmic differentiation in this case? Well, do I have an x in the base? Do I have an x in the exponent? Yes. So I'm going to go ahead and use logarithmic differentiation, which means take the natural log of both sides first. That is always step one in this process. All right, and then remember the point of doing that is so that I can pull that x out of the exponent. And an exponent within the logarithm becomes multiplication out front of the logarithm. And so I took this natural log of x and moved it out front, which left me just with the natural log of x on the other part. So the right side actually ends up being just natural log of x times natural log of x, which we can use product rule for, although you didn't have to. As a side note, although I don't think anybody would have chosen to go this way, you could have rewritten this right side as the natural log of x squared, and you could have done it that way, if you preferred. We get the same thing. But let's go ahead and proceed using product rule. So then, derivative of both sides now. That's going to give me 1 over y times y prime equals, actually I'm skipping a step there, I don't want to do that, 1 over x times the natural log of x plus natural log of x times 1 over x. And so if I then multiply by y on both sides and do a little simplifying on the right side, I end up with y times the natural log of x over x plus the natural log of x over x, which of course can simplify even further, right? So on the right side then, I am also going to substitute back in for y here. So that becomes x to the natural log of x times 2 natural log of x over x on the inside.